In this video, let's take a look at calibrating some imported GPS vectors to our survey's coordinate reference system. If I drop back out here, you can see the data that I picked up. You can see where the RTK vectors are. I'm going to zoom in on my control points up here. And I probably could turn off these lines here. So let's go ahead and turn those off. Jump back out there. These are mile grid markers. So you can see I've got just over a mile between my base points here on the north end and about 4 miles or so between these points here. The white points, mod 136, 137, mod 135, are the GPS control points. 137 was the base point that we used for most of it, that we did our RTK from. And then county 136, 137, and 135 are the published monument locations from the county. And I know that when I bring GPS data in, I'm always several feet off if I just hit the here button to kind of get my location, depending on what the satellite constellation is that day. And so that's kind of what I expect here. And we're going to calibrate this then to bring my GPS data onto my survey grid. So let's take a look at a couple of things here. Here are the county monuments from the county, their published coordinates. And I went ahead and put together this little GPS control point traverse because I just wanted to see how far away I was. So from my base station 137 to the county point is just under 4 feet. From 135 to the county feet is 3 feet. From 136 to the county's monument 136 is 4 feet. That's about where we typically come in this area. So I know that that's what the calibration is going to correct for me. Now, I could use this traverse as the calibration. That's what I'm going to do. I could also come in and when I pick point pairs, I could say I want mod 136 to calibrate to county 136. But since I already have them in a traverse, I'm going to use the traverse to find the calibration points. So let's right-click any one of these, go to Calibrate. We're just going to double check that we're doing the one imported field data traverse. And then I'm going to create a calibration. Now, I've already got this traverse set up with the control points as side shots. So I'm going to select a traverse of uncalibrated points with calibrated points or control points as side shots. And this is the traverse I want right here. So let's choose OK. Traverse PC is going to go ahead and create that for me. It's going to do a 2D conformal transformation with a vertical shift because it saw that I had elevations on my control points and heights converted to elevations on my GPS points. So I've got a difference there and it wants to pick that up for me. And so it created these point pairs, 137 to the county 137, mod 135 to county 135, etc. And then it computed the results for me. So right away I can see very little scaling, very little rotation. Here's my vertical shift to get from the GPS heights to my elevations in my coordinate system. And then I'm looking at some of the statistics, and I usually drop right down to my standard errors. So I've got a standard error here of 500ths in the Y, 400ths in Y. Okay, these are pretty reasonable. And I get those 3 points. So I could come back and create a calibration out of this. I could say I'm going from my assumed location when I hit the here button to my Kansas North NAD 83. Okay, so that would create a calibration for me and I could calibrate the data. However, I want to show you something here that's just a little bit different. I went ahead and in the field put in the ties to the control points with a pound sign. Here's 137 and I put pound county 137. So I knew that that's the point that it tied. Here's my 135 and I put pound county 135. Here's my 136 and I put pound county 136. I still identified it as a control point. But what this does for me now, I want to show you, it allows me to get statistics on all the points. So I'm going to do the same steps again. I'm going to calibrate this. I'm going to create a calibration. But this time I'm going to select, instead of the side shots, I'm going to say I want to put the control points in the description delineated with that pound sign, and those are all in the imported field data. So I'm going to use that same data that I imported as the traverse that holds both the uncalibrated and control points for the computation. And you'll see here real quickly why I'm doing that. So I still just have those same three, I guess I have four because I tied 137 again. So I still have just those same points that I'm using for the calibration. And I still compute my calibration parameters. But watch what happens. As I scroll down, I have statistics, the standard errors, on all the other points. And the reason I want to show you this is that I start out not too bad, a couple of hundreds, but watch what happens as I scroll down through the points. I'm going to go down here pretty far. Okay, now I've got some that are a tenth out. I've got, here's one that's 1600ths out. Okay, I've got another one that's a tenth out. I'm just kind of looking through these for any larger values. And the reason I wanted to show you this is that that's really what I expect. If you look at my control here, I've got just sort of a small area that I've put control in, but I've got points that are extending way, way, way down here. And the deal with calibrations is that I really want to contain all the points I'm going to be calibrating with control points. So I really would be wise in this situation to not only have these control points up here, but probably come down and pick up another control point way on the south end of this, and probably something over here on the east side. And by containing those, I now extend the statistics of the calibration over the whole area. And I don't have these outliers where I'm kind of extrapolating the errors out because I'm outside of my control area. So I just wanted you to kind of see how that works. I wanted you to see how we could create a couple of different traverses to do this for us. And then I'm just going to follow right through on this and tell Traverse PC that I want to tell it where I'm coming from and where I'm going to. I'm going to go ahead and save this. And I used GNSS here, and I said include all points. So that's the one that had all of the points in it. Okay, so now I've saved that calibration, and now I can actually go calibrate it with the Calibrate button. Traverse PC goes through and calibrates everything. Now I can still come in and undo that if I want right from here. But I'm just going to drop back through to my report here. And here's a report that shows exactly how much each of those points was moved. Okay, and I can go ahead and print this out. I probably want to go back and make sure I'm getting the elevations in here as well. Stick that in the folder. And now I've used a calibration in here that's part of the survey. So I can use this calibration over and over again for this job. I can even come into the survey and tell it I want to create a site calibration with that calibration I just created. And I want to have it handle all geodetic points. So anytime I bring in GPS or GNSS point now, based on the same system I was using for that base station out in the field, it'll automatically take care of that calibration for me. And the last thing we can do here really quickly is just go ahead and look at those points, make sure that they're looking good now. And I would expect then that now I'm within 400ths, I'm within 600ths, I'm within 200ths. That's what that calibration did for me. It just rocked all that GNSS data right onto my coordinate reference system for my survey.